Hello everyone, my name is Luis Gil, and today I'll be walking you through my analysis of predicting pleasant weather on different stations in Europe using a supervised model of machine learning algorithms. The focus of this presentation is on comparing different models and assessing which perform best with weather station data. I want to mention before proceeding that please feel free to follow me on my YouTube channel, which is called Gil the Analyst. Also, you can check my portfolio or most of my projects on my GitHub website. You can click on the links of these logos. Also, feel free to follow me on my LinkedIn social network for more information about me. Now, I want to define the objective of this project, which was to determine which supervised learning algorithm best predicted pleasant weather across multiple weather stations. For this project, we used different models, as I said before. I used the k-nearest neighbors, which I will explain a little bit further on the next slides. Let me put my, okay, I also use artificial neural networks and decision tree, which I will explain further later. It is important to mention that the data came from multiple weather stations in Europe, included but not limited to Belgrade, Budapest, Oslo, and others. There were some biases in the dataset due to missing data from certain stations, like for example, as we can see here, let me look for the pointer. One moment. No, that was not. Okay, Roma and Gdansk. In addition, weather variability across regions could introduce some prediction biases. Some stations, like for example Oslo or Basel, had higher accuracy, while others, like for example Maastricht, show lower accuracy possible, indicating some data irregularities. So, regarding optimization of the data, scaling played a crucial role in improving the model performance. Initially, the data showed high variance in mean and standard deviation across stations. After scaling, the data was standardized, which helped the models to perform better. For example, for K and N, we tested different K values with a K equal to 9, giving the highest testing accuracy of 45%. Now let's discuss the algorithm we use for this project. As I mentioned before, I use the k-nearest neighbor, KNN, which is an instance-based learning algorithm used for classification. It works by finding the k closest data points, which means their neighbors, to the input data based on the distance metric, like Euclidean distance, for example. The model assigns the most common class among the nearest neighbors to the new data point. In the study, we experimented with different values of k to determine the best number of neighbors, balancing training accuracy and testing accuracy. On this case, we did an initial training accuracy of 1, which led to overfitting. I tried with different k values, and the final testing value I did for k, it was the value of 9, which led to an accuracy of 45%. I also use artificial neural network, ANN, which is a model inspired by complex classification tasks. It consists of multiple layers of nodes connected by weight, which learn a pattern in the data. I use a multi-layer perceptron as our ANN, which adjusts weights during the training to improve predictions. The number of layers, nodes per layer, and learning parameters were tuned to maximize the accuracy. So we use hidden layers of we use hidden layers of 150, which led to an accuracy of 74%, which is our best result. Higher precision, let me see, the higher precision was observed in well-presented stations like Basel, Belgrade, and Budapest using this model. And last but not least, I used the decision tree model, which is a tree-structure model using for both classification and regression. It basically splits the dataset into a smaller subset based on certain conditions, creating something like a tree structure where each leaf node represents a class or decision. The decision tree tends to overfit if it's not prompt. In this project, I analyzed its accuracy and observed that although it captured many details, it required careful tuning to avoid overfitting. So to summarize the results of this project, we have that KNN worked well with tuned parameters, but suffered from overfitting at low K values. So we got the best result for K equal 9. The ANN, the neural networks model, performed better after scaling and adjusting the architecture, and the decision tree required some pruning to avoid overfitting, which is what it was not the best model for this particular project. As the next step, I highly recommend exploring more advanced models like, for example, random forest or gradient boosting. Additionally, larger datasets or different weather attributes could offer further insights. Future analysis could also focus on anomaly detection using an unsupervised model. And that was all for this presentation, presenting the results of this project. Thank you very much for your attention. If you have any questions, feel free to ask, reach to me, to my email or to my LinkedIn profile. Feel free to also check my GitHub repositories or projects, and you can also check my YouTube channel for more content about data analytics and data science. Thank you so much. Have a great day. Have a great week. Be safe. Keep learning.